Hello everyone, welcome back to Electrochemistry Hub. In today's video, we are going to discuss one of the most important concepts in electrocatalysis, overpotential. Whenever you read a research paper, you come across statements like this catalyst shows a overpotential of 220 millivolt at 10 milliampere per centimeter square. But have you ever stopped and asked yourself, what exactly is overpotential? Why do we need an additional potential? If water splitting starts at 1.23 volt, then why are researchers applying 1.5 or even 1.6 volt? If you have had these questions, don't worry, by end of this video, you will understand not only to calculate overpotential, but also why it exists. Let us start with a simple question. Suppose I ask you, at what potential should oxygen evolution occur? Many of you may already know the answer. The thermodynamic potential for oxygen evolution reaction is 1.23 volt versus RHG. This value comes from thermodynamics. In simple words, it tells us that OER become energetically favorable at 1.23 volt. Now, here is my next question. If I apply exactly 1.23 volt, will oxygen gas start evolving rapidly? The answer is no. And this is where the overpotential comes into the picture. Let us understand this with a real life example. Imagine you are pushing a car. If the road were perfectly smooth and the car had no friction and there was no air resistance. But in real life, what happens? There is a friction between tire and road. There is air resistance. The car has weight. So you have to push harder than the ideal force. Electrochemical reaction behave in exactly the same way. Although thermodynamics says the reaction can occur at 1.23 volt, the reaction does not proceed fast enough because it faces several obstacles. We need to apply extra voltage. This extra voltage is called overpotential. So what is overpotential? The simplest definition is overpotential is extra potential applied beyond the thermodynamic potential to drive an electrochemical reaction at a practical rate. For oxygen evolution reaction, thermodynamic potential is 1.23 volt versus RHG. Suppose your LSV shows that catalyst reaches 10 milliampere per centimeter square at 1.48 volt versus RHG. Now let's calculate the overpotential. Overpotential eta equal to applied potential minus thermodynamic potential. So applied potential, when we apply 1.48 volt, current reaches to 10 milliampere per centimeter square. So applied voltage is 1.48 minus thermodynamic potential for OER is 1.23. So eta equal to 1.25 volt or 250 millivolt. Now you can ask me why we need to report overpotential at 10 milliampere per centimeter square. Why not in other current density? For universal comparison, people always choose to report overpotential at 10 milliampere per centimeter square. So now the question is, okay, this catalyst exhibit overpotential of 250 millivolt at 10 milliampere per centimeter square. But why this extra potential is required? What are the reasons? What are the sources of overpotential? There are three main sources. First one is activation overpotential. Activation overpotential is the energy required to transfer electron across the electrode-electrolyte interface. Generally, it is caused by slow reaction kinetics. This activation overpotential depends on the catalyst. Usually, it is dominant at low current densities. For example, OER on platinum electrode require much activation overpotential Then the thermodynamic value, because OER involves 4 electron transfer and multiple intermediate. Second reason is ohmic overpotential, caused by which is caused by voltage loss due to resistance. Sources include electrolyte resistance, electrode resistance, current collector resistance, and contact resistance. These are because of these kind of resistance, we need extra overpotential. Those are called ohmic overpotential. Third one is concentration overpotential, which occurs when the reactant cannot reach the electrode surface fast enough. During HER, hydrogen bubbles cover active sites. During OER, oxygen bubbles hinder electrolyte access. This becomes significant at higher current densities. So, all these, because of these three reasons, we need extra potential, that means over potential, to drive an electrochemical reaction, so that the next time you read a paper saying our catalyst shows an over potential of 210 millivolt at 10 milliampere per centimeter square, you will know that this means that catalyst needs only 210 millivolt of extra energy beyond the theoretical 1.23 volt to drive the OER at that particular. And that's exactly why researchers are always trying to design catalysts with lower and lower overpotential. Thank you so much for watching this. If this explanation helped you understand the concept of overpotential, please like the video, subscribe to the channel, and share it with your friends and fellow researchers. Thank you.